In this video, we're going to take a quick look at the versatility eCADSTAR offers designers with respect to thermal pad connections. This is a great example. Here we have a net with 4 different pad sizes, the smallest being the QFN package Rectifier. You can see that the output is being decoupled by 2 caps and then it transitions from layer 1 to 2. At the transition point we have a device that appears to be shorted out, but it's going to be used as a current sense device. We'll look at this closer in a moment. The same thermal spoke width is not going to suit all these different pad sizes, so outside of flooding them all, what options do we have? Well, in the first instance, the thermal connectivity preference is assigned to the copper flood, to the shape. In the settings for the copper flood, we can define thermal or flooded, and we can also isolate vias from pads. But this setting is then applied to all pads that make contact with that particular copper flood. If I change the settings, you can see the impact on the pads. Here the smallest dimension of any of the pads on the QFN is 0.3 millimeters, so I will set my minimum spoke width for that copper flood to 0.3 millimeters. Now let's review the impact if I decide to flood all those pads and have no thermal relief. I'm not happy with that result, so I'm going to Ctrl Z and undo it. But eCADSTAR offers another level of flexibility that is really easy to configure. We can override the shape, the flood connectivity preferences, by defining them at the next level down, which is at the device pads directly. I've just changed the 2 large decoupling capacitors to have flooded connections. Now focusing on our current sense device, I'm going to change one pad to flooded and the other pad to isolated. I also need to replicate the unconnected connection at the QFN device. Now you can see both of those pads are connected to the same net, the output net, but they are now isolated from the copper flood. The reason we've isolated these 2 pads is because the rectifier has an inbuilt current monitoring facility. If the pad that measures the current is connected directly to the copper flood, then the measurement will be inaccurate. We need to measure as closely as possible to the final output stage before the conductor travels around delivering its power to the receiving circuits. eCADSTAR's flexibility regarding the thermal, flooded and isolated connections makes this really easy for us. We are not just limited to overriding the copper flood connectivity with flooded or isolated connections, we can also define different thermal connectivity. So in this example I can pick a pad, change to a really thin spoke width and specify any number of spokes, up to a maximum of 12. Where possible, it will add as many spokes as it can. In this instance, it achieved 5. Just for fun, let's see if one of the larger pads can handle 12 connections for us. So there you have it, a huge amount of flexibility regarding thermal connectivity in eCADSTAR.